Well, good morning, everybody. Um, so I was out this morning. I was at the Inglewood Cemetery, and I found this mushroom here, which I believe is a chlorophyllum, possibly a green spored parasol. But I'm not certain about that. And honestly, my mushroom identification skills can use a lot of work. But I wanted to bring it back to the lab. One, I'm probably going to try to culture it and maybe barcode it just for practice and study it a little bit, maybe look at it under a microscope. One thing I'm noticing already is when I touch it, it bruises brown. So that's kind of interesting. But I wanted to talk about it in context of electroporation, because this week and these videos have been about preparing E. coli cells to do electroporation, but turns out you can actually electroporate fungal cells as well. You can collect some spores and you can fire some DNA, electroporate the DNA into like Aspergillus canidia or spores, and possibly do that with other kinds of mushrooms as well. And so electroporation, we're learning it because, well, I need to use it for agrobacteria. I need to put some plasmid into some agrobacteria that I'm going to use to then put into fungus. But it's a good skill to learn because you can use it for more than just bacteria. You could use it for experimenting on maybe mushrooms like this or other kinds of mushrooms. So it's kind of a good general purpose tool. And one question that I've been asked before is, well, why are you doing agrobacteria? Why don't you just use the electroporation or some of the other methods for doing fungal transformations? And it's a good question because, well, agrobacteria is definitely more complicated. It definitely requires more steps. You know, you're dealing with you're introducing a whole other organism into your pipeline, your workflow here. I've never worked, you got to work with E. coli and then agrobacteria and then the fungus itself. So the reason why is because, well, there are a limited number of species that have a defined protocol for doing transformations with electroporation. And one of the challenges with using electroporation to do fungal genetic engineering is the transformation rates are not that great, even for the ones that we know, even for the different Ascomycetes and various molds that it's used for. And so eventually the goal is to be able to make engineering mushrooms, Basidio mycota mushrooms like these, make this more accessible and at least teach the mushroom growing community how to engineer mushrooms so that they can bring that to the lab, bring that to the community, and who knows what people will come up with. And agrobacteria is a good just sort of like general purpose methodology for approaching new species because it's not very particular from species to species. It will just do the gene transfer. And also, it's a very widely used tool for approaching new species of mushrooms for which there are no documented transformation protocols. I would be willing to guess that this chlorophyllum here has never been genetically modified in a lab. Now, I could be totally wrong. I've not done a literature search for that. But because this is possibly poisonous and there hasn't been any immediate science or value that people have been able to kind of think of in terms of like why they would genetically modify it, I don't know that there's been a lot of research on how to actually GMO a mushroom like this. And so agrobacteria gives us a blunt tool to approach new species like this and some of the other ones that I'm working my way up to. So that's kind of some background on why I'm kind of going over electroporation and why it's an important part of this procedure. And I think maybe down the line, I may try to actually put the Spanish plasmid in an aspergillus using the electroporator. But for now, the main purpose is to use it to put my Spanish plasmid, which if you don't know the background on all of that, the Spanish plasmid is some DNA that has a green fluorescent protein and some promoters and terminators that have been documented to work in Aspergillus and some other molds. And so that's kind of what I'm using to drive the learning forward. Okay, so we are in day 4 here. Yesterday we created the liquid culture, so let's check on that, because if it turns out it's good, then we will be able to go ahead and make some plates today and do some our first electroporation experiments later today. So let me pull this out, and I can tell you right now, look how cloudy it is. So that's great. That means the E. coli that we revived from that really old stab is growing, and so it's good. So I'm gonna take this out, tighten the lid here so nothing spills, and I'm gonna bring that into the lab. And the other thing I'm gonna do is bring this, kind of show you the plate that we made yesterday. You can see how much more it's grown. Look at all of those colonies. And that's exactly what we'd want to see in a good streak, because it allows us to like get at those colonies and pick them out and do experiments with them. So this is probably good enough that I can take it out of the incubator and put some parafilm around it and pop it in the fridge, and then I'll have another plate with some good growth that we can use for later experiments. Oh yes, the other thing is, so let me get back over here real quick. Okay, so I was reading through one of the papers that I mentioned before, and I thought that it said you only needed to wash it once. I think I'm gonna sneeze. Excuse me. And I'm looking at this here. So it says we're gonna harvest some bacteria from the lawn that we're gonna grow today, and we're gonna suspend it in 1 milliliter of DDH2O for E. coli and mix well until there's no clumps. Then we're going to centrifuge it as normal. And then it says we're going to repeat the centrifugation step as done before, twice more, for a total of 3 washes. So it looks like this protocol has us, even though it says it's a rapid protocol, it looks like we still have to wash it 3 times. So that's kind of a bummer, but we're gonna do it. So no big deal. Okay, to wash that, if you notice it said we need to wash it with DDH2O. Well, I have some here. Now, it says to do it in a refrigerated centrifuge, which is pretty common, and it says keep everything cold. But then I have that other paper, because remember, we're testing 2 papers. The other paper says do everything at room temperature. But I can tell you from my experience with heat shock transformation that the centrifuge step actually heats things up. And so what I'm going to do is I'm going to kind of do a hybrid approach. And this is all experimentation. That's kind of the point of this week, is I'm going to put this in the fridge. I'm going to chill it, because when I go to wash the cells, in order to keep the cells a little bit cooler and prevent them from overheating and dying, I'm going to try and keep them cool just by using the cold DDH2O. The other thing is we're going to need cuvettes. And so these are used cuvettes. These are cuvettes that I've previously used before and sterilized and cleaned. And this up. And so these are the cuvettes here, and these are going to be what we're going to use later today. And yeah, so I'm going to keep those. I had them in the freezer to keep them really cold, but we're trying to test if we can do this at room temperature, so I'm going to leave that there. So let me get some plates out and go ahead and make a couple of plates using this seed culture that we created yesterday. And then I'm gonna let those plates incubate for about 4 hours, 4 to 6 hours. And they should have a nice thin lawn of bacteria that's grown over them. And we'll scrape that off, and we'll use that to create our electroporation mix here. So let me get set up and I'll show you how I do that. right, we can now take these plates, which have had 150 microliters of the seed culture, and go ahead and put them in the incubator. And we're gonna let them incubate for about 4 to 6 hours. So that should put me towards the end of the day today, but I'll check back in with you, and hopefully we'll have a nice lawn, and hopefully we'll be able to do our first electroporation experiments today. See you in a bit. All right, guys, it's that magical time where we're going to do our first electroporation experiments. We have 3 plates here, and they all have nice thin lawns. See if I can find a way for you to see that. You can kind of see a little bit of the discoloration there that in my reflection. That's a lawn of bacteria. So let's take that over to the lab here. And I'll tell you what I'm gonna do. I'm going to take this loop here, and I'm gonna wipe it across here gently, and I'm gonna take probably 4 loopfuls, and I'm gonna spin that into 1 milliliter of ice cold DDH2O, just basically sterile water. And then I'm gonna spin that down 3 times, and each time I'm gonna dump out the water, I'm gonna put new water in there and resuspend it. And then finally, it's going to be resuspended in 40 microliters of ice cold water. And then that's what we're gonna put into our cuvette, and that's what we'll try to shock today. So let me get the camera set up and create my samples to work with, and then we'll get to the shocking. Here we go. Coming off. You see that? See how like there's still just a lot of bacteria in there. And I know that the more I bang this loop against the side, the more damage I'm doing. So what I think I'll do is, let me put that down for a second, is I think what I'll do is clean it. And I think I'm gonna use the colony picker side, because I might be able to just get more cells that way. Now on this one, I'm gonna put a lot more. Look at that big chunk right there. So we have our 2 samples here. We have A and we have B. Here's A. And here's B. So you can see B is just a little bit more opaque. Okay, so now we're gonna go ahead and put them through a wash cycle. So what I'm gonna do is pop these in for 5 minutes, actually 4 minutes. And then I'm gonna dump them out here, and then I'm gonna do this wash 2 more times, and then I'm gonna do a final resuspension in 40 microliters. So here we go. Okay, we've done the washing steps. Let me bring over the tubes. So I have these tubes here of A and B. These are both suspended in 40 microliters of sterile water. What I'm gonna do now is, I've already wiped all this stuff down, and I don't know if you can see it. This is kind of my work area. I'm gonna go ahead and place the 40 microliters in these cuvettes here. So let me do that now. So we'll do A first. So I'm just gonna suck that out. It's interesting that there is a lot more volume than 40, probably because of the solids. So 40 is not a lot, but that's what the protocol calls for. And so I'm gonna stick this down in the middle. And there's really not, there's just a little bit in there. I don't know if you can see that, but it's a little bit in there. Okay, and I'm going to pop the lid on, give it a little tap. It's definitely making a connection to both sides. Now I'm gonna put that in and make sure there's a good contact up here. Hopefully you can see that. Let me just double check. Get this up a little bit higher. Okay, now we're going to, probably should have done this before, turn on the machine. And per the protocol, we want to set the capacitance to 25, which we've done. We're not using the capacitance extender, and I happen to know from other reading that the pulse controller needs to be set to 200. We need to set the volts though. We're going to set that to 1.8, let's see, yeah, 1.8 kilovolts. 1.8. Man, I feel nervous for some reason, probably because I've spent all week preparing for this, and here we are. And okay, so the plan is I'm gonna hit these two pulse buttons. If all goes well, we're gonna hear a beep, and then there's gonna be a time constant, and the time constant we're looking for is about 5 milliseconds. When that's done, I'm gonna use one of these micro transfer pipettes and move it to the recovery broth that we'll put into the incubator for an hour. And for this test, I'm really just testing to make sure that I haven't killed the cells with the washing steps, and that the electroporator doesn't kill them either. Okay, I guess, should we do it? Okay, here we go. We got a 0.5, and I don't know if you saw that, but it sparked. Okay, not great, but let's go ahead and practice. Okay, so we have the first one done, and I think it didn't work. We have a 0.5 millisecond constant, and I saw a spark. I don't know if you guys saw it, but I saw it. So let's do another one. So I'm gonna take cuvette, I'm gonna take B, and I'm gonna take 40 microliters of B. I think I know what's going on. This suspension is very, very thick. I think I maybe used too many cells. I don't know if that makes a difference, but it did spark, so. Okay, here we go. Put this back in, and let's do it again. 1.8, here we go. Woo! Big spark on that one. Another 0.5 time constant. Okay, so first two. Done. Okay, so let me show you this work area. Okay, let me show you this work area. So these were the original cell suspensions, A and B. That's what I washed. And even though I added 40 microliters at the end, there's still, the volume ended up being a lot greater than 40 microliters of water. So that's something to note. Number one is I would think that if I resuspended these in 40 microliters, I should pull out most of the material, most of the bacteria that's resuspended, but look how much is left even after pulling off 40 microliters. And then, so I put the 40 microliters in each of these cuvettes. Kind of see that, and it's not a lot, it would just add just a little bit to the bottom. And then afterwards I use these micro transfer pipettes because I don't have pipette tips that will fit all the way down into the cuvette. And I transfer them to these recovery tubes, which I've marked AA and BB. So I will go ahead and put these recovery tubes into the incubator and just see if the cells lived. But in terms of did it work or not? Well, no, I think I heard them both pop. I heard them both spark right here, and we did not get a good time constant. So my hunch is that I was probably adding too many cells. I probably scraped off too many cells and put that in there. I'm not sure, but if you guys know, tell me. Otherwise, you know what? We could try it again tomorrow and see how it goes. I have some other plates, so we'll try very, very little tomorrow and see if it works. So I'll let you know if those recover. Otherwise, electroporation test number 1 is complete.